So hi everyone, today I will talking about vector collinear in 3D. And here I have a question writing down. A and B and C have a coordinate of 2, 4, 6, 6, 6, 2, and 14, 10, minus 6. And from this, the information we've given, we were asked to solve the component of A and B. To find the component of A and B, to find the vector A and B, you need to take the B, the second vector, take away the first one. And our B vector is 6, 6, 6, 2, minus A vector, which is 2, 4, and 6. 6 take away 2 give us 4, 6 take away 4 give us 2, 2 take away 6 give us minus 4. And here we have the component of A and B. But also, if the question didn't ask you about the component, they ask you about the coordinate, then that will be written in bracket 4, 2, and minus 4. And this will be the coordinate form. And for second question, it asks us to show that A, B, and C are collinear. And what does it mean by collinear? A collinear is the vector that have a common point and also a common multiple. So by proof that A, B, and C are collinear, on the previous question, we found out the component of A and B. So now we need to find the component of B and C. So by finding the component of B and C, we need to take the third C vector minus the B vector. So in this case, the C vector is 14, 10, and minus 6. And minus away the B coordinates, 6, 6, and 2. And 14 minus 6 gave us 8. 10 minus 6 gave us 4. Minus 6 minus 2 gave us minus 8. And so here we have the component of B and C. And then does A and B have the common multiples? Let's have a check. So 4 and 8, they have a common multiple of 2. Does 2 and 4? Yes, they have a common multiple of 2. Minus 4 and minus 8, a common multiple of 2. So yes, A and B are collinear. And then the third question we have here is find the value of the ratio of the value of AB to BC. So from the previous question, we found out that the common multiples are 2 from each t, so that we can tell that this one is twice as much as AB. BC is twice as much as AB. So the value of AB and BC will be the ratio 2 to 1, because our vector BC is twice the size as vector AB, which gives them the collinear of 2 in different ratio. So that proves that AB to BC is 2 to 1. Today I'm here going to talk about vector ratio in 3D. And here we've got one question. P divides AB in the ratio 3 to 2. If A is the point, has the point minus 3, 1, 1, and B is 2, 1, minus 4. And the question here is find the coordinates of P. So as usual, I would always draw the graph first. So here is our P, here is our A, and here is our B. So on here, this part is 3, 2, 2. So the first thing we need to do is find the whole length of A and B vector. So to find the vector of something, you need to take the second letter of the vector, take away the first letter of the vector. And in this case, our B is 2, 1, minus 4, minus by A, which is minus 3, 1, and 1. And 2 takes away minus 3 is 5. 1 minus 1 is 0. Minus 4 take away 1 is minus 5. So here we get our vector AB. And now, to find the vector A and P, we need to take 3 over the 5th, because this, together this is 5 part, and AP is 3 over 5th of the whole part. And then times that by the whole length of AB. And this gave us 3 over 5 times like 5, 0, and minus 5. And to find the AP, we need to take each number in the vector divided by the denominator and times by the numerator again. So 5 divided by 5 times by 3 equals 3. 0 divided by 5 times the 3 equals 0. Minus 5 divided by 5 and times 3 equals minus 3. And here we get our AP. And then after we get our AP, we need to find out what the P is. The vector P equals 3, 0, minus 3, which is we get for our AP, plus minus 3, 1, 1, plus our point A, which is 0, 1, minus 2. So the coordinates of our P is 0, 1, and minus 2. Hi everyone, today I'm talking about vector 3D scalar product. And the information given to us for this topic is in a triangle ABC. The vector AB has the component of 3, minus 1, and 4. AC has the component of minus 1, 2, minus 1. And the first question we need to find out is the value of AB, vector AB times vector AC. And by finding that, we need the both to 6 numbers from vector AB and AC. So the first thing we need to do is vector AB times vector AC is we need to take the first letter of, which is I, of each component and times them up, which is 3 times minus 1, and then plus minus 1, 2, plus 4, and minus 1. And this will give us the value of vector AB times AC. And 3 times minus 1 is minus 3, plus minus 1 times 2, minus 2, plus 4 times minus 1, minus 4. And this gives us minus 9. And here is the answer for vector AB times AC. And now, here is the second question. Find the side of angle BAC. And I'd always like to draw the graph first. So here is our A, and this is the angle to find out, which is theta. And this is our B and C, and we know the size of this vector AB and AC. Now let's go. So we need to have a rule to find out. This is the rule to find out the value or the two vectors together, and that's the magnitude of A times magnitude of B times by cos theta, which is the unknown angle. And by changing them, theta equals cos minus 1 A times B over magnitude A and magnitude B. And then we can now start doing the question. So first off, we need to find out the magnitude of A, which is the magnitude of vector AB. And by using that, we need to use the magnitude rule, x squared plus y squared plus z squared, which gives us 3 squared plus minus 1 squared plus 4 squared, which equals square root 26. And our magnitude of B is our AC, which equals to minus 1 squared plus 2 squared plus minus 1 squared, which gives us square root of 6. And then from the previous question, we've got the value of AB times AC. And now we're going to put that. So that's A times B, so that's minus 9 over square root 36. No, sorry. Square root 26 times by square root 6 equals cos theta. And cos minus 1, the answer we have for the previous answer, equals theta. And by putting this formula, the answer you get for this one, in front of cos minus 1, and it will give you approximately 136.1 degree theta. So the angle BAC equals 136.1 degree. Thank you.